Good morning, good afternoon, may even be good evening. This is Kevin Jackson from Trilio. Thanks for taking the time out of your busy day to join us for our bi-weekly Ask the Expert series focused on cloud-native data protection. Our aim is to provide relevant topics and discussions around various data protection challenges in a quick 30-minute lightning talk style format. We'll do our best to stick to the time, although it's not me doing the talking this week, so we might actually stick to it this time. We'll default to everybody to mute. You'll appreciate the fact that we don't want everybody swearing at John all at the same time. So we want to keep everything nice and quiet. But that said, we do want to keep it interactive. So submit any questions you have about the topic to me directly, and we'll get to them at the end. With that, I'd like to introduce the ever-charming, witty, charismatic, and incredibly intelligent, hold on, they're John's intro notes of when he introduced me from last time. I'm kidding, over to the one and only John Tobin with today's topic.
Oh, thanks, Kev. Right back at you, buddy. All those things are true, by the way. And Kevin's right. If you want to swear at me, raise your hand and take your turn. To get a little bit into what we're going to talk about today, why don't we take a look at the agenda? So we'll go through a quick introduction on what we're hoping to achieve with this series, and then we'll dive into NFV. So, what is NFV? How does it function? What drives NFV today? So why is it so important? Why is it becoming even more important? Why do you need to back it up? And then I'll close it out with my best piece of advice for anybody who's on this call when it comes to NFV and vendors in general. Then we'll do some Q&A at the end. So a little bit about the Ask the Expert series. As Kevin said, it's a bi-weekly discussion on backup and recovery. We like to keep everything interactive here, so your interaction is encouraged. So ask us questions, please. Type them in the chat. You can send them directly to Kevin. Bring any concerns, any challenges you have. Right, this is it's an open forum for everyone. And the most engaged person at the end of the webinar, we will reach out and give you a $50 Amazon gift card. So it works for everybody. So who are we? If you've been on the last 2 weeks, you've heard Kevin Jackson. Nice little animation there. That's how I earn my money. Kevin does a great job, and I'm sorry I don't have a charming British accent like he does. But I'm John, and I cover all of the Americas while Kevin covers all of EMEA. So let's get into the topic a little bit. So, what is NFV? I took this from our great partner's website, Red Hat. It's really a way to just virtualize network services. Traditionally, networks had always been done on proprietary hardware. It took a long time to procure. It was expensive, and it was difficult to get in. And it was also difficult to plan. So just like virtualization for server resources became very popular for the agility and speed, so did virtualizing networks, or network function virtualization. Became popular for networking. Networks for about 10 years, I don't know, maybe you could even argue 30 some odd or 40 some odd years behind virtualization for computers, but we got there. So what is NFV all about? There's basically three components. The first one is the VNFs themselves, so virtualized network functions. And these are basically the worker bees. These are the network functions that are actually providing things to you. Most of us today are probably getting this webinar over NFV. It's very popular. All right, so these are things like routers, DNS, firewalls, intrusion detection. There's a lot of them. And then there's the NFV infrastructure itself, what's termed the NFVI. So this is the infrastructure platform that is giving these VNFs access to the physical world itself. And today, a lot of these VNFs are running on top of OpenStack and VMware. But tomorrow, there's a real shift to containerized network functions. Most of these are running in Docker, but some of them are running in other containerization platforms, and they're being orchestrated by large platforms that we've all heard of, things like Kubernetes, Apache Mesos, DCOS, Red Hat's OpenShift, and just Kubernetes upstream as well. And then the last piece, and kind of the wrinkle in this whole thing, is the MANO. So that's what it's termed. It stands for Management and Orchestration. And there's really two components that comprise this MANO framework. One is the NFV orchestrator itself. So this is actually responsible for provisioning VNFs and managing their dependencies, because oftentimes they're provisioned in what's called a service chain. So there are many VNFs which are their own atomic piece, but they're all put together in a chain to provide a full network function. A lot like microservices you hear about today are in a particular application. You could think a lot of that as the VNFs in their service chain. Now, once the orchestrator does its thing, the VNFs are actually handed off to an NFV manager. And it's really responsible for maintaining the state of these NFVs, knowing whether or not they're ready and they're fully provisioned, or they're just in a provisioning state, so to speak. It's also responsible for monitoring them, healing them, or calling back up to the orchestrator to spin up new VNFs in a new service chain. So those are the components. But before we get into a little more on NFV, I'm going to give you a little warning. In case you're allergic to physics, I don't want anybody breaking out in hives during the presentation. Nobody wants to have to call the paramedics. So we're going to be talking a little bit about the speed of light. Not a lot. You can just block your ears if you want, close your eyes. Doesn't really matter. But if you need to leave right now because you're allergic to physics, you should do so. So what's driving NFV? This is kind of an interesting conversation. The first thing is competition, right? Competition kind of drives a lot of what we do in the market today. But if you think of platforms like Skype, right, which was revolutionary, maybe revolutionary for, I don't know, 2004 or whenever it came out. But it was disrupting a lot of what the telecommunications industry was doing, in particular phone companies, right? What at the time was costing you 30 cents for an international call, you could now do with video for free. So that's big. And what powers these platforms is agility, right? They have the ability to scale up fast as users come on. A lot of this is driven by the virtualization of networks themselves because they're so core to their operations. And then that extends to things like Netflix today. Not only is it disrupting content generation, but it's also disrupting content distribution, and is able to do so by having the agility and flexibility to use services like VNFs. Same thing with things like YouTube TV, right? Disrupting the cable industry and allowing IP networks and virtualized networks to provide you with content that's normally done over a cable box. And additionally, we have things like the push to 10 gig, right? We've all heard about this in some way, shape, or form, whether it's 5G for cellular or the newer DOCSIS 4.0 standard for things like cable modems, right? And these are both promising to push 10 gig connectivity to our home, in theory anyways. But there are some challenges that come along with this. But think of this, really, is now a cable modem provider, like your cable company, and your cell phone provider have the ability, once these standards are fully implemented and figured out in the real world anyways, to both be your internet service provider, right? So your internet service provider now can come from your mobile company, right? That's a big thing. So how does this relate to NFV? So, VNFs and CNFs are traditionally thought of as stateless, right? That's the way they've been traditionally provisioned. That's the way they traditionally work. They don't have state in them. They're just responsible for doing a thing. They just do the thing without really thinking about it. They have really one task. You have that service chain built up, and there is no state that goes to them. There's no database behind. They don't treat you as an individually any different than they treat any other individual. I'm just part of a bucket brigade. I grab the buckets, I pass the buckets. I grab the buckets, I pass the buckets. That's how they work. And today, this is somewhat correct, right? But there are cases where we actually do have VNF state. Things like modem registration. So we were talking about DOCSIS 4.0. If you walked upstairs, it's upstairs for me, but if you walked over to where your cable modem is, if you're using a cable provider, and you looked on the back of your modem, chances are you'd probably see the DOCSIS logo, right? It's been around for a while now. And modem registration is important because there is a DOCSIS endpoint very close to you, most likely. And that DOCSIS endpoint is running as a VNF, and it's responsible for your modem registration. If it loses the database with your modem registration info, basically your modem has to reboot and re-register with that DOCSIS. And if you've ever done that, you know it takes a while. It takes, it could be 45 seconds, it could be a couple of minutes, depending, right? But that's disruptive. During that time, you have no network connectivity for your entire home. It's a big problem today, right? In our new world. Also, you have things like intelligent routing. As things are getting more and more high speed, right, and there's more and more congestion on networks, intelligent routing needs to be able to get around bottlenecks in the network. And it needs to know the current state of things in order to be able to do that, right? And so this is stateful information about how do I get around, right? Think if you're navigating through traffic and there's an accident somewhere, you need to know how to get around it. The network needs the exact same thing. Also, there are things like intrusion detection, right? This is very important for secure networks, almost any network, right? You don't want an intruder to be able to cover up their own tracks because everything wasn't stateless. I could just kill that VNF and nobody will ever know I was here. Well, if you have stateful information, that won't be the case. And then tomorrow, we're talking about 5G. So we're talking about 10 gig connectivity. How is that going to happen, right? Well, in order to be faster and have more bandwidth, you need lower latencies. So physics, and this is where the speed of light comes into play. So plug your ears if you think you're going to get hives. But the speed of light is going to require us to push things to the edge. It has to be closer to you if you want to access it faster. There really isn't much way around that we know of today anyways. So that state's really going to be decentralized. It's going to be pushed out to the edge. You hear a lot about edge computing today. This is one of the reasons why it's so popular and such a buzzword, so to speak. It's because it's really important. So how do you protect these stateful NFs, whether they're CNFs or VNFs? It really doesn't matter so much for this particular topic. But protection is actually really easy for network functions. A lot of the conversation comes in around, do I actually need to protect this network function because it's stateless? Chances are you probably don't. It's protected already by the MANO, by that orchestration and management layer, and it can just be respun up. But for protection, you can actually maintain your usual backup strategies, and it really depends on the platform that you're in. So, Trilio is integrated into both OpenStack and then also into Kubernetes and OpenShift today. So, if you're using OpenStack, a lot of times you can use Cinder or Nova backups. You can also probably use the Cinder or Nova volumes because they may not get corrupted. So really, if you spin up a new VNF, you can just attach the same volume to it. But if it does get corrupted, then you need something like a backup strategy that has a known good copy of that volume. And so you can use things like Cinder and Nova backups, but they're very difficult to manage at scale. There are also some open source projects like Carver or Freezer out there, also very difficult to manage at scale, and you have no support. So we have a backup solution available for OpenStack, and it can very easily back up the VNFs and the volumes attached to them and restore them for you. We'll talk a little bit about restore in the next slide. If you're on VMware today, you can really pick your solution, right? There are a lot of different vendors out there. I'm not necessarily an expert on the VMware platform, but you can evaluate, and I will give you some tips on how to evaluate your vendors as well on a later slide. And then if you're in Kubernetes, well, things are kind of easy. They're also kind of interesting. You can use persistent volumes today. You have things like the CSI driver that's driving people towards the ability to be able to use their enterprise storage behind Kubernetes. And so if you're using CSI, or if you're just using regular old PVs from a previous version of Kubernetes, and you don't disrupt them and you don't corrupt them, then it works a lot like OpenStack. You can spin up a new CNF and you can attach the old PV to it. However, if you corrupt those, then you're in an interesting state where you might need to restore them. You can use something like Trilio, which has a Kubernetes native application, also an OpenShift native application, and certified with Red Hat, that you can spin up right inside to protect your CNFs and any other workloads that are running on Kubernetes. So here's where things really get interesting, is how do you restore these network functions? Well, there's a real problem. And the problem is that the VNFs are managed resources, right? We have that Mano layer that's registered these VNFs, and is responsible for managing them. So anytime you're going to spin up a new VNF, or if a VNF dies and you want to restore it from something like Trilio, an OpenStack integrated backup platform, well, we can spin that VM back up for you. That's great, right? It's right back there. Or is it? Because the management and orchestration layer needs to know about that VM. And if I just spin it back up for you into OpenStack, it has no clue it's there. It doesn't have a service chain. It's just a VNF with no real brain. Yeah, it's like the scarecrow from the Wizard of Oz. So what you need to do is you need to re-register that VNF. And so the way you can do that is if you have an NFV integrated backup platform, like maybe Trilio for OpenStack, you can actually use that backup solution to provide a stateful image back in. So think in OpenStack, if you're familiar, you have Glance, which is basically your image repository. We can provide a Glance image into OpenStack that you can then use by, let's say, UUID to spin up a new VNF with the orchestrator, and just use that stateful image that we've provided as a way of spinning up that VNF. So what you get is the goodness of registration inside the Mano layer. So inside the orchestrator in the manager, they can now manage this configuration of this VNF, and we can give it the stateful information back that it has so that it can function properly and get back on to what it's doing. So now let me give you a little bit of a piece of advice. One is evaluate your backup options wisely. Always ask yourself the question, is this going to be a partnership? Whenever you're talking to a new vendor, doesn't matter who it is, if you let this be your guide, you'll always make the right decisions. Now, there are things that you don't know, of course, right? You can never know anything, but ask yourself, is this going to be a partnership? And some important things to evaluate about whether or not this is going to be a partnership is this vendor interested in openness, right? Openness is going to be key for another point I'm going to make in a second. And when I'm talking about openness, I'm talking about open standards like APIs, right? Can I easily replace this piece that I'm making this investment in if something isn't right? And an open API is very important for that. You also want open formats, right? So are they writing things in open format that I can use later on with other libraries? Or am I dependent on this particular piece of technology for a critical piece of my platform and of my service and of my network? All right. And on top of that, are they compressing or encrypting it with proprietary keys? Can I ever get back at this if I need to? Right? These are all important. And so you may be asking, why? Why is this important, John? Well, why is kind of simple, right? Because proprietary is not flexible. And today, everything's about flexibility. If I want to trust somebody, I should have the trust in them that if anything goes wrong, they trust in me to make the right decision and to move away from what's happening right now, right? And if they provide me with the flexibility, I have the ability to be able to do that if I have to, right? A partnership is all about making things work, but sometimes you do have to move in different directions because things don't work, right? And if they lock you into something because they are proprietary and inflexible, then that inflexibility is going to make everything monolithic. And today, we're trying to get away from monolithic everything, right? The reason why the mainframe's been dying for 25 years is because everything's monolithic. But because it's monolithic, it's so hard to get away from, right? And so if I were going to give you one piece of advice, not as somebody working for Trilio, just as somebody who's been in the industry for a while, I've got a lot of gray hair now. It's try to avoid that if you can. And with that, I'm accepting Venmos as of right now. The presentation is technically over, but we do encourage you, this is a joke of course, please ask questions. We want this to be an open format. So I guess over to you, Kev.
Yeah, thanks. There's got a couple of questions, but whilst John and I just go through this, if there's any more questions that want to be passed over, again, just a reminder, just send them through directly to me, and hopefully we'll get to them in the next couple of minutes. So we do have a couple of questions. One of them, I don't think it was touched on in the presentation. It's around DR. Is, you know, in terms of backup and recovery, in terms of disaster recovery scenario, where does that fit in the NFV world? Because obviously it's all about uptime in NFV. So where does DR fit in, and where does, I guess, you know, adding my flavor onto this, you know, given the fact I'm in a Trilio hoodie, where does Trilio fit with DR and NFV?
Yeah, it's a good question. You know, certainly, I think, you know, when it comes to things like disaster recovery, there are a couple of critical pieces. One is that mano layer, right? You kind of have to be able to back that up, and also be able to recover it if there's ever a disaster, right? That's the most critical piece of things like NFV. So that's pretty important. You know, when it comes to the VNFs, obviously, if there is a disaster, are things like state important, depending on what the disaster really looks like? Is somebody going to mind if their modem re-registers, right? These are decisions that you really need to make, and there's no real answer there. Or can I just, you know, respin things up with the mano layer if I need to, right? So that's one component. Is it possible to do things like DR with Trilio? Yeah, we make them really easy for you. In you know, a platform like OpenStack, things are tightly coupled because there's multi-tenancy. So they're strictly owned by one user or another, and a resource of a particular OpenStack cloud. But we can allow you to replicate that data and restore it to a different OpenStack cluster in a different location if you want, very easily. And we have a feature that we've written to make it easy for our customers that allows you to reassign those UUIDs. So change that ownership to a new cloud and restore all of those workloads in. So yeah, you know, I think it's an important conversation to have, and it depends on your SLAs and you know, what you want to do as an enterprise. Not sure if you have any other viewpoints on that, Kev.
No, I think, as I say, the key thing there is obviously about restoring the state, because I think there's that perception of VNFs and CNFs, you know, being stateless, you know, as you described. But of course, there has to be state. You know, if anything, you know, the management layer at least is your state at the very, very least. Mm-hmm. So you know, if you're not backing up that particular platform with a view for disaster recovery, you know, I think that's an urgent requirement to obviously to be addressed. Got another question here in terms of the evolution of NFV. You know, it seems to be, and I'm just going to paraphrase this question a little bit, so I do apologize. The NFV landscape seems to be evolving. Where does Trilio fit in that evolution? You know, from I guess, and again, just adding my twist on this. You know, in terms of like a basic NFV to a world of orchestration. You know, how is Trilio fitting into that particular journey?
Yeah, that's a good question. I mean, the VNF world and the NFV world is still kind of relatively new. You know, think like, I don't know, maybe 5 to 7 years old. So there is a lot of pushing, you know, forward and changing of it. I think, you know, where NFV seems to be going is, it's going to become more and more widely used, I think, and it's moving more and more to containers because it's a very container-like use case. So, I mean, in the evolution of NFV itself, I mean, it's still kind of evolving. So we're all figuring it out together. And we're also pushing towards more containerized workloads, which NFV is as well. So I think, in that respect, this is kind of an open-ended question. In that respect, where we are going towards containers as well from a native backup perspective. So we're kind of following where, both application development is going, towards containers, and also where NFV seems to be going, or NFC, I guess, in this case. So, I think we're following right along. And I think the whole industry, when it comes to things like software development, which is basically what these VNFs are, which is software, is kind of pushing in the same direction. But I'm not sure if I quite answered the question. Do you have any other thoughts, Kev?
Yeah, I do, and I'll be very quick because there's one more question that I think we'll just get to, and I do realize the time, but yeah, I just want to add my color on that, and I agree with the direction in terms of, say, moving towards CNS, because I see that evolution of the natural architecture of VNFs, or more so CNFs. If it is on a Kubernetes type platform, I would see the management, or certainly the orchestration layer of the Mano to actually interoperate with Kubernetes itself, in terms of like actually using that as the orchestration layer. And from there, a kind of twist on the tail, as it were, obviously that's where, Trilio Vault for Kubernetes fits in quite naturally. And so it starts to answer some of those challenges in terms of the orchestration piece, where software naturally has been developed, to suit those particular platforms. So I see that direction from VNFs to CNFs, and I would hope to see that the orchestration layer to actually start to standardize on what's already there, as part of the orchestration engines that are currently available. One last question, I say, I just want to get to it, just the last thing, and it's about, so it's got here, how does Trilio fit in with the growing edge services requirement with 5G rollout? So we're talking about, at the edge.
Mm-hmm. Yeah, no, it's a good question. The way that we fit in is, that edge a lot of times is going to be, well, depending on the architecture, could be kind of its own cluster, so its own cloud if it's an OpenStack, its own Kubernetes cluster, or it could be managed centrally, right? And Trilio plays a key part in backing up that entire infrastructure. So sometimes there's a centralized piece of the network, right? The control plane might be running centralized, and then you have a bunch of edges that are connected to that control plane, or it could be its own, Kubernetes or OpenStack cloud, like I said. And so Trilio can be there no matter what the architecture is. Obviously, we want to be careful about the way that we architect the solution, but I think the way that we're going directionally, the way that our Kubernetes platform is architected is in line with being able to protect those edges very well, and being able to restore the edges as well as well as any stateful information, which we talked about is going to be kind of a requirement for 5G, just because the latencies have to be so low.
Yeah. So I think we're out of time. So I thank everybody. I mean, John, thank you. For that great presentation. Let me just wrap up with the winner of the gift card this week. Is going to be Ravi Velanini. We'll email you the details of that. So yeah, thank you for your participation and for your presence today. Just to wrap up, we're very happy to announce that due to the success of these sessions, we're going to be extending the series into July and August, covering more topics around OpenStack, Rev, and Kubernetes. And as you can see on the screen here, we've got another session from John who will be going through what are the common considerations for RPO and RTO, and that's going to be on the June the 25th at the same time. So yeah, thank you everybody for your time and patience today. It's very much appreciated, and hopefully we'll see you in a couple of weeks.